In Lab 6.3, our purpose is to use base 10 pieces to introduce the concept of percent and to illustrate and solve various percent problems. So the manipulatives that we will use will be our base 10 pieces. So if you'll please find those. We're going to let the square, the large square, represent 100%. And so this would represent 10%. And this would represent 1%. So if we want to represent 25% using our manipulatives, then we would have two tens, and we would have 5 units. And so we have 25%. If we want to represent 30%, then we have 3 of those. So this represents 30%. Adding in these now represents 35%. So a percent represents hundredths. Sometimes students get the misconception that you can only have 100%. But immediately, if you tell them about bonus, if your test is worth 100% and you can get some bonus points, then you might earn 110%. If you get 100 on the test and you get a 10-point bonus, then you would have a 110%. Or if something doubles in its value, let's say that you buy a coin and that coin cost you $100, but now you can sell the coin for $200. Then you have your original value back plus 100% more. And so we can represent values that are more than 100%. Now we can also use graph paper to model percent by making our 10 by 10 grid. So if you don't have these pieces, you can also do the lab with graph paper. Now, let's say that you have 100%, but the value of this, let's say that you're purchasing a car, a go-kart, for $300. Well, that's 100% of the price you're going to pay. So if I want to know what 1% of that would be, let's say Grandpa's decided he's going to pay 1% of your go-kart price, then you can divide that by 100 because we have 100 squares. So each square has a value of $3. So let's say now Grandpa's decided that he's going to pay 30% of the price. Well, we just said that one square is worth $3. And so if he's going to pay 30 of them, then he's going to pay $90 on the go-kart. Or let's say Grandpa decides he'll pay 30%, but Grandma says she'll pay 60%. Well, you have 10, 20, 30, 40, 50, 60 squares. And so each square has a value of 3. So 60 times 3 means that Grandma will pay $180 and Grandpa's going to pay $90. Therefore, $270 is paid for, and you then would only have to pay $30. Okay, let's say that we have the same scenario and you decide to sell the go-kart. So you have paid $300 for the go-kart and you want to double your money. So you now have 200% of the price of the go-kart. And so if each square has a value of 3, and you have 200 squares, then 3 times 200 means that you're going to earn $600. So you have 100%, which would be the total cost of the item, and you find out what 1% of that would be, and then you can calculate any value. The word problems that go along with percents are sometimes very confusing for students. For example, let's say that you have the value of 30% of 150. So if we want to use our manipulatives to calculate that, 150 is the total. So that's the 100% of this total situation, or it's like the go-kart. This is 150%, or not percent, this is 150, which is 100%. that means that each square or each 1% has a value of 1 5/10. So I have 30%. So I have 30 1 5/10. How about 45? So 30% of 150 is 45 because 1% is 1 5/10, and you want to figure out what 30% would be. So you're taking 1 5/10 times 30. All right, let's look at another example just like that. What would the value of 75% of 150? So if I look at 150 and I know that each square has a value of 1 5/10, then I can take 75 times 1 5/10. Let me move that up so you can see better. Have one decimal place to mark off. So the value would be 112 5/10. Okay, now let's look at a different what we just did is the percent of the whole. So we knew the percent and we knew the whole. So we could use our manipulative and find out what 1% was and then multiply by the percent. All right, the next problems that we want to look at are the part of the whole. So in this case, what we're looking for is the percent. So what percent of 450 is 45? So we still know that 450 is the whole, and we know that 45 is the part, so we're looking for the percent. So remember that this is the whole, 100%, and so if I want to know the value of 1%, I know that 1% would be 100 divided into 450, which is 4 5/10. So each percent or each block has a value of 4 5/10. And so now I would want to see how many 4 5/10 it would take to make 45. And I would find that there would be 10. So that's 10%. So it would take 10 of these squares, since each of them has a value of 4 5/10, it would take 10 of those to make 45. So 10% of 450 is 45. Now notice in doing this lab, I have not in any way given a rule. We are just looking at the manipulative. From the manipulative, we're able to calculate the percent. All right, let's do another percent of the whole. So let's say that we want to know what percent of 450 is 108. So 450 is the total, 108 is the part, so I'm looking for the percent. So again, 100% is 450. So 1 square, 1%, 450 divided by 100 is 4 5/10. So I want to know how many 4 5/10 sections I can take out of 108. So 45 will go into 108 twice, and 45 will go into 180 4 times. So there would be 24%, or 24 squares, that would make up 108. So again, that's taking the total and the part and finding the percent. The other situation that you would encounter would be that you know the percent and you know the part. So this problem would look like this. 6% of what number is 24? So now we have to calculate the value of each square, and we have 6 squares. So if we have 6 squares that have a value of 24, then we will try to see the value of the total by taking 6% into 24. So the total would have to be 400. So 6 into 24 means that each of these would have a value of 4, and you have 100 of them. So 1%, so I could just take 6 into 24 to get 4. So each square has a value of 4, and you have 100 of those, so that would be 400. All right, let's look at another example. If you have 40% of what number is 30? So now I need to figure out what the value of each, so I have 40 squares, and what would the value of each be? So I know that they have to be less than 1 if I have 40 and they only have a value of 30. So if I take 40 into 30, that's going to be 75 hundredths. So each square is 75 hundredths, and I have 100. So that means that the total is 75. All right, I would like for you to think now of how fractions and decimals and percents are all related. And there are some that you need to know and probably do from using them so often. When you have the fraction 1/2, if I change that to a fraction with a denominator of 100, then I have my percent. And if I have the percent, then I also know the decimal. So having a denominator of 100 is the key to getting a percent and a decimal value. If I have 3/4 and I make a denominator of 100, then I have 75 hundredths, which is 75%, which is 75 hundredths as a decimal. All right, these are the problems that I would like for you to do in Lab 6-3 to model with the manipulatives. Okay, so you have these four problems to respond to on Lab 6-3.